Hello everyone, welcome back to my YouTube channel. This is part 3 of laws of motion. In the previous parts, we have discussed about relative motion, distance and displacement, speed and velocity, uniform and non-uniform motion, scalars and vectors, acceleration, distance versus time graph and velocity versus time graph for each cases. If you haven't watched part 1 and part 2, do watch the videos. The link is in description. So let us start with today's lecture. So let us recall what we have learned in the last video. So acceleration is rate of change in velocity. So in last class we learned that acceleration is nothing but change in velocity upon time. In the distance time graph, the slope of the straight line indicates the speed of the object. Third thing we learned that in the velocity time graph, the area under particular quadrangle will indicate the distance traveled by the object. For uniformly accelerated motion, the velocity time graph is always a straight line. For non-uniform accelerated motion, the velocity time graph may have any shape depending on how the acceleration changes with time. Now these points we have learned in the previous video, and if you want a detail of that, do watch that video. Today we will start our new subtopic, that is equations of motion. So Newton studied motion of an object and gave set of three equations of motion. Now these three equations of motion are related to quantities like velocity, time, acceleration and displacement, provided that all the acceleration or the acceleration of the body remains constant. So these equations are only applicable, or they can be only applied to such objects, such bodies whose acceleration remains constant. These relations are collectively known as the equation of motion. There are three equations of motion. Let us study them one by one. Let us study first the first equation of motion. The first equation of motion provides us relationship between initial and final velocity, time and acceleration. The equation of motion is as follows. V is equal to u plus at, where v stands for final velocity, u stands for initial velocity, a stands for acceleration and t stands for time. The second equation of motion provides us relationship between displacement, time, acceleration and initial velocity, and the equation is s is equal to ut plus at square by 2, where s stands for displacement, u stands for initial velocity, t stands for time and a stands for acceleration. Similarly, the third equation of motion provides us relationship between initial and final velocity, acceleration and displacement. And the equation is v square is equal to u square plus 2as, where v stands for final velocity, u stands for initial velocity, a stands for acceleration and s stands for displacement. Now these three equations of motion can be proved by different methods. So first today we will prove it by obtain this equation by graphical method. So how to obtain this equation by graphical method? Let us study them. Now let us start with the derivation of equations of motion using graphical method. Now as I have said that the three equations of motion are only applicable for that objects which are in uniformly accelerated motion. So if we plot a graph of uniformly accelerated motion of velocity versus time, the graph is a straight line as you can see in the figure. Now in this graph, the object is starting from point D. So here the initial velocity is marked at point D, that is u. And the velocity of the object is increasing, and after time interval t, the object reached point B, and the corresponding velocity is marked at point C, that is v. So u is the initial velocity, v is final velocity, and the object has traveled in time t. So let us write what we have concluded by seeing the graph. So first thing is the initial velocity. So initial velocity is nothing but u. Final velocity is v, and time interval is small t. Now from the graph, you can observe that u is nothing but the distance OD. Distance OD is nothing but u. So I can write initial velocity is equal to OD. Again, the distance OC, this is equal to V. Second and final velocity is equal to V, that is equal to OC. And similarly, for time, I can write distance OE is nothing but T. So time is equal to T, that is distance OE. So these three things I have observed from the graph. Now to prove the first equation of motion, which states that V is equal to U plus AT. Now in this equation, we need velocity, final and initial velocity, acceleration and time. So here we have initial velocity, final velocity and time. Let us start from the definition of acceleration. Now what does acceleration tell? Acceleration is nothing but change in velocity upon time. Now what is change in velocity? Change in velocity is nothing but final velocity minus initial velocity. So write here final velocity minus initial velocity upon time. Now we know that what is final velocity and initial velocity. From the graph, we have observed that final velocity is nothing but OC minus initial velocity is OD upon OE, and OE is nothing but time. So we will write it T. And this is nothing but acceleration, and we denote acceleration by small a. So from here we have found an equation, created equation, that is A is equal to OC minus OD upon T. Now from this equation, if we rearrange this equation, we get OC minus OD is equal to A into T. So I've just sent this T to left hand side. So it becomes OC minus OD is equal to AT. So this is what we have observed. Now from the graph, what is OC? From the graph, OC is nothing but V, OD is nothing but U is equal to AT. So V minus U is equal to AT. Now rearranging this again, we will get V is equal to, we will shift this U minus U to right hand side. So it will become U plus AT. So this is our first equation of motion which we have proved from the graphical method.
Now let us derive the second equation of motion that tells us the relationship between displacement, time, acceleration, and initial velocity. For proving the second equation of motion, we'll use the same graph of velocity versus time where the object is in uniform accelerated motion. So from the graph, again, the object is starting from point D. So U is the initial velocity. And at, at time t, the object is at point B where the final velocity is V. So let us make assumptions that let A be the acceleration, let U be the initial velocity, let V be the final velocity, and T be the time. Now, the second equation of motion, in the second equation of motion, we need to find the displacement. Now, in order to find the displacement, we have already learned in the previous video that when a graph is velocity versus time, the area under the graph gives us the displacement of the object. So here, what is the area under the graph? So the region which I am shading with red color, this is the area under the graph. So we need to find this area in order to find the displacement of the object. So let us find the area of this graph. Now you can see that in order to find the displacement, that is S. So for displacement, which is noted by S, it is equal to area of quadrangle DOEB. Now you can see in the graph that we can split this area into two parts. The first part will be a rectangle and the second part will be a triangle. So we can write the further step as S is equal to area of rectangle DOEA plus area of triangle DAB. Now we know that what is the area of a rectangle. So area of a rectangle is length into breadth. So here you can see that length is OE and breadth is AE. So we can write that OE into AE plus area of triangle is given by half into base into height. From the graph, we can say that base is DA and height is BA. So area of triangle DAB will be half into base is DA into height is BA. Now let us replace this distances OE, AE, DA, BA with some values. Now from the graph, we can say that our initial velocity, that is u, is nothing but OD. So this value is nothing but OD. This is nothing but u. So I can write that initial velocity u is equal to OD. Now, since this is a rectangle, opposite sides are equal. So if this is u, then AE will be also u. So initial velocity is equal to OD. It is also equal to AE. Similarly, from the graph, we can say that this distance OC is equal to V. So OC is equal to V and also BE is equal to V. So I can write final velocity is equal to OC, which is equal to BE. And time is nothing but distance OE. So I can write for time is equal to OE. So from the graph, we made the conclusions that distance OD and distance AE are equal, and that is equal to initial velocity. Distance OC and distance BE are also equal, and they are equal to final velocity. And distance OE is equal to time. Now we will replace this in the formula. So let us proceed with the next step. So I can write S is equal to, in place of OE, I can write time, that is T, into, in place of AE, I can write initial velocity U plus half into, in place of DA. Now you can see that DA is nothing but equal to OE because this is a rectangle, so opposite sides are equal. So DA will be equal to OE. So for time, I can write time is equal to OE, also equal to DA. So in place of DA, I will also mention T into BA. Now in order to find AB or BA, what we need to do? So I am finding the value of BA here. Now from the graph, if you observe, value of OC is equal to V, value of OD is equal to U. And if we subtract OD from OC, so OC minus OD will give us BA or AB. So V minus U will be equal to BA. So we substitute this value here. So in place of BA, I can write V minus U. I hope you understood this step. Let us move to further step. Next step will be, therefore I can write S is equal to UT plus half into T. Now, in my formula of equation number 2, my equation is S is equal to UT plus half AT square. So here acceleration is missing. So I need to replace this V minus U with acceleration. Now we know that acceleration is nothing but change in velocity upon time. So I can write acceleration is equal to change in velocity upon time. If I replace it with symbols, A is equal to V minus U upon T. So in place of V minus U, I can substitute A into T. So I will substitute in place of V minus U, A into T. So my next step will be S is equal to UT plus half into T into A into T. So my final step becomes S is equal to ut plus half a t square. Since there are two t here, t into t will give t square. So this is my second equation of motion. And I have derived the second equation of motion with the help of graphical method. I hope you understood how we derive second equation of motion with the help of velocity versus time graph when the object is in uniform accelerated motion. Now let us discuss the derivation of third equation of motion, which gives us the relationship between displacement, acceleration, and initial and final velocity. Now, this is the equation in which time is eliminated. In this equation, we don't have a factor of time. For proving this equation also, we'll use velocity versus time graph of a body moving in a uniform accelerated motion. Now, here also we need to find the displacement. So we need to find the area of the quadrangle DOEB, as you can see here. But here we will not find the area in two parts as rectangle and triangle. Here we'll consider this as a one shape because this shape is nothing but called trapezium. Trapezium is the shape in which two sides are parallel to each other. So as you can see, side OD and side BE, these two sides are parallel to each other. So this shape is nothing but trapezium. First, let us write the observations from the graph. So here U is nothing but initial velocity. V is nothing but the final velocity. T is nothing but the time. A is nothing but the acceleration. Right? And S is displacement, which we need to find now. For displacement here is nothing but equal to area of trapezium. Area of trapezium DOEB. Now the formula for area of trapezium is equal to half into sum of parallel sides, sum of lengths of parallel sides. Sum of lengths of parallel sides into distance between parallel sides. Now from the graph, OD and BE, these both are parallel sides and OE is the distance between them. So if I substitute this here, I will get S is equal to half into OD plus sum of lengths of parallel sides. So OD is my first side and BE. These two sides are parallel and we have to add the two sides into distance between the two parallel sides, that is OE. Now again coming back to graph. Distance OD is nothing but initial velocity, that is U, value of U. So I can write U is nothing but OD. Distance OC is nothing but V and OC is also equal to EB. So I can write V is nothing but, that is value of final velocity, V is nothing but equal to OC and OC is nothing but equal to BE. Time is equal to OE. So I've made three conclusions from here. U is equal to OD, V is equal to OC, which is also equal to EB, and T is equal to OE. Now we have to substitute these values in the equation. So my next step becomes S is equal to half into, in place of OD, I will write U plus, in place of BE, I will write V into, in place of OE, I will write T. Now this is my equation 1. Now, as you can see, equation 1, it is a relationship between displacement, initial velocity, final velocity, and time. But as I said, in the third equation of motion, we don't have a factor of time. So we need to eliminate this time with acceleration. So we'll just make use of the definition of acceleration. We know that acceleration is equal to change in velocity, that is v minus u upon time. So we can write t is equal to v minus u upon a. And we substitute this t is equal to v minus u in upon a in equation number 1. So my next equation becomes s is equal to half into v plus u into, in place of t, I will write v minus u upon a. Rearranging this equation, I can write as s is equal to v plus u into v minus u upon 2a. So I can write v plus u into v minus u is equal to 2as. Now in algebra we have one formula, a plus b, a minus b is equal to a square minus b square. We'll apply same formula here. V plus u, v minus u will give you v square minus u square. And that will be equal to 2as. Rearranging this equation, we can say that v square is equal to u square plus 2as. And this is our third equation of motion. So we have proved all the three equations of motion with the help of graphical method. And I hope you understood how to prove these equations of motion using graph.
And I hope you found this video interesting. Do like, share and subscribe our channel. We'll meet in the next video and we'll continue the chapter. Thank you.